Hi there, my name's Vince from mymatevince.com, and in this video today I'm going to be attempting to fix this faulty fridge freezer. So my fridge broke about 2 months ago and I've been meaning to fix it ever since it broke, but I keep putting it off. Now, with all these fix-it videos, please do not take this as a how-to video. The chances are I'm going to be doing things incorrectly, the terminology I'm going to be using is wrong, and I've never fixed a fridge before. So take this purely as entertainment, but I will do my very best to fix this fridge. Now, I did try and fix a fridge about 3 years ago, the one in the garage, but unfortunately I couldn't get it to work. Even though I bought a new compressor for it, or a second-hand compressor, I still couldn't get it to work, and annoyingly I couldn't actually pinpoint the fault. So it's kind of put me off trying to fix fridges because I had quite a failure with it before. Now, luckily for me, we got a new fridge for the garage, so the very fact that this isn't working isn't that big a deal because I've already got a fridge in the house. But like anything, when you get used to having 2 fridges, it's hard to go back to 1 fridge. So my wife's been on at me now for a while to fix it. Now, the strange thing is, the freezer's working absolutely fine. You can still see that there's ice there, and up until this video, there was food in the freezer that I've had to cram into the other fridge freezer. But annoyingly, the fridge is not working. Now, when you look up here, it appears to be working, because if I move this little knob round here, then for example, you can see it's black up top for the fridge and black down the bottom for the freezer. So at the moment, it says, see, it's freezing now. If I move this, move it to 2, then what will happen is I can come back later and it will say 2, but it's definitely not 2 degrees in here. What I did is I got a cheap thermometer from eBay, put it in here, and as you can see, it's reading 19.9, which is far too hot for a fridge. So the background is there was a power cut for about 4 hours. When the power came back on, my fridge was beeping at me, which I thought meant that it wasn't at the correct temperature. Pressed a few buttons, the beeping went away. The next day, my wife said that the milk was warm and the butter was getting soft. So obviously there was a fault with the fridge. Turned it on and off thinking it might just need to be reset, and it hasn't worked ever since. I don't know if it's related to the power cut or whether it's just coincidence, but either way, the fridge is not working anymore. So what I'm gonna have to do is pull it out, because this is a built-in one, so I presume I'm gonna have to take the doors off, pull it out. I think I just have to undo these to take the doors off, and then I get it out into the kitchen, have a good look and see what it can be. Now, I know when I tried to fix my last fridge, most people said that fridge problems are to do with the thermostat, and I can definitely see that there's something here which must measure the temperature. So maybe it's going to be an easy fix, maybe not, really haven't got a clue. Thinking because the freezer works and the fridge doesn't work that this must have 2 separate systems, one for the fridge and one for the freezer, but I'm not going to know that until I start taking it apart. Maybe something will be really obvious, maybe it will be a nightmare, haven't got a clue, but either way I need to take it out to examine what's going on. So that's what we're going to do in this video. So let's undo the screws here, and also here and down the very bottom as well. And I'm hoping then the fridge then will be separated from the cupboard carcass and also the front doors as well. And I'm hoping if it's not too heavy, I'll be able to kind of wobble it out from here. I'm not sure if there's going to be any other screws anywhere. I'll have to have a good look. But what I need to do before any of that is I might as well turn it off, because there's no point in having it on. So let's turn it off. Let's do the screws. Right, okay, so that's good. So it looks like these have now been separated from the actual carcass of the kitchen cupboard itself, yeah? So that's good. So now hopefully I'm just dealing with a normal fridge freezer. I might as well take these out completely. Right, okay, so it definitely seems to be loose up the top, because if I open up this door here and just give it a little bit of a wobble, I can sort of see that it's moving, yeah? So that looks like it's not screwed in there, but if you have a look down the bottom here, can you see that it's actually screwed into this bit here? So I'm going to have to undo these 2, and there's also just one there. Okay, that can pop out as well. So then after that, it should be all loose. Okay, so I've got it out, and yeah, like the other fridge, you know, just seems so simple at the back, But that's the problem. You know, there was loads of different things. I'd have loads of different things to test, but you've just got this thing here, which is, I was going to say warm, but it's not really. But I think the way a fridge works is it doesn't make the fridge cold, it takes the heat out of the fridge. So it's not that cold air is getting pumped into it. I just believe that the heat is being removed from the fridge, and that's what makes it cold. But if we have a look down here, we have what I believe to be the compressor. Now this is slightly warm. We've got a little tray here, which is something to do with, must be like overflow with the condensation and stuff like that. Now this is a frost-free fridge, so the freezer's always frost-free, bit of a tongue twister. So I don't know whether you know that pipe's got anything to do with that or not. But again, I don't have to get involved with any of that. I can see here it's a little bit sort of flaked up a bit. But remember, this is working, or is this working okay? Maybe the freezer works differently. This is the problem. See, I do not know. So the power from the electric goes into here, the main supply goes into there. Looks like there's some kind of like starter or something at the back there, not too sure. Compressor, and then, again, I don't really know. But the thing is, I can't see any thermostat or anything there, so it looks like I'm gonna have to get into the actual fridge, up to that top panel, you know, that digital panel at the top, and it looks like I'm going to have to remove that to see what's going on. So maybe I have to take off, do you know what, I'll probably have to take off the top. Let me have a look there. Yeah, there's screws there. Alright, maybe I'll just have to take off this top bit and maybe it will all become apparent. That's just a bulb in there, and I was hoping to find this cable go into the back, but it doesn't, so maybe the cable goes up to here somewhere. So maybe I need to lay this... No, I think what I'm going to do is I'm just going to work off a chair, because I don't really want to be laying this on the front or the back, because I might end up damaging something. So I'm just going to work on a chair, and I'm going to see what's going on here, see if I can get access to this in here. So the camera's on the tripod, which is balancing on 3 chairs. I'm also on a chair to get the height to film and get on top of this as well. Now it looks like there's, it looks like there's a door bolt here. So when I undo this, the door is going to come off, which will actually make it easier for me to get access to everything. Aha! Here it all is, look at it. Right, okay, so it looks like everything goes back to here, including the thermostat. And we've got a part number there as well, so that must be the thermostat for up here. What I'm not sure about is whether the freezer has a thermostat or whether it just goes by what the temperature in the fridge is and then, for example, reduces it by 15 degrees or 20 degrees or whatever it is. Right, okay, but that's good. That is good. So I think what I need to do is, first of all, we know it's getting power. Maybe check the thermostat as the first thing to check. Oh, actually, hold on. There's two. Look, there's 2 ones here that go off. Let me zoom in a little bit to show you. If you have a look at this plug here, it looks like this is the white cable, and there's also a brown cable, and they both go to this one here. So I wonder whether you have to. I wonder how you connect them up to that. Oh, okay, I think it looks like similar to a telephone wire thing, where basically it's like a metal V and the wire gets pushed into it, and as it gets pushed into it, it pierces the insulation and then touches the copper core on the inside. Oh, right, okay, well, let's undo that. See, what I'm thinking is, if the thermostat was faulty, it might not be calling for the cold. So let's say now, if it was, I mean, again, I'm making this up, but let's say now if the thermostat is open, then it could be the other way around, but if the thermostat is open, then the fridge will keep making the top part, the fridge, colder and colder and colder until it closes. and then it won't put any more power to make it cold. And then as it starts to heat up again, then it will open up, and then it will put power to it again to make it cold. Well, let's say now if it was just constantly closed, then the fridge wouldn't know to give it power. Now I'm not sure if that's it, because as I say, the freezer's working fine, but that could possibly be it, couldn't it? This one here does seem to be a little bit loose. It's only wobbly, it's not actually popping out. And also that cable looks to be connected to this blue and brown, which says to me that it's going to be more power related. Well, I think what I'm going to do is I'm going to make a note of this part number on here and pump it into Google and see if it is a thermostat or not. So I typed in this number here into Google and it wasn't really bringing anything up. There is a crease in the label, so there might be some numbers hidden just in there, so I was kind of guessing them. But I couldn't find, it didn't really bring much up. So what I did is I just Googled freezer cold, fridge warm. And this actually makes a lot of sense. I never knew this. Remember I was talking about like 2 different circuits and stuff. But, as I say, I don't know if it's the case for this one here. But it looks like in a fridge freezer what happens is the fridge freezer works on pumping cold air into the freezer. And then from the freezer, that cold air is then borrowed and it's shoved up into the fridge. And if you have a look down here, there is actually vents. Yes, I'm thinking that maybe this is the one to either blow the air out and maybe this is to suck it in, or maybe that's to blow it out and this is to suck it in, I don't know. But that air is then pumped into the fridge, which must be coming through this bit here. So what I'm thinking is when you adjust the thermostat, you know, on this thingy here, maybe it just kicks the fan in and out that allows it to draw it into the fridge. And when the fridge gets to temperature, the fan turns off, and when the fridge starts to warm up and it needs to be cold, the fan kicks in. Now, as I say, I'm not 100% sure, but I think rather than messing around with this here, because remember, this is just a probe, and the actual thermostat part of it is probably built into this board. Now, worst case scenario, maybe I can get a spare board there, but I'm thinking it might well be a problem with the fan maybe kicking in and out, so maybe it's blocked, or maybe this board here isn't giving the fan the signal to kick in. Now remember, this is all just guesswork, but I think to start with, what I'm going to do is I'm going to undo screw there, screw there, screw there, and a couple of screws here and here, and see what's inside here, and then it might make more sense. Maybe a lot of people said that it's a frost problem, so if everything gets furred up with frost, then maybe the fan stops working. I mean, this does look relatively frost-free. I can see that there's just a bit of ice up here. Now, on a frost-free fridge, I'm not sure how much ice should remain, whether it should be perfect or whether there should be a little bit like that. I really don't know. But yeah, so that's what I'm going to work on now. Okay, so those 3 screws are out. Now, just in case I didn't make it clear earlier on, this is completely disconnected from the mains voltage, so there's no voltage going into this, so it's going to be safe to work on. Right, okay, so we got something here. Now, if I was to take a guess, I would say that that was the cable down the bottom that was part of that condenser or whatever, goes up to here, and this is just a connector to bring it up to the top, you know, the circuit board up the top. That's what I think that is. So they all look to be nice and secure in there, so I'm not gonna mess around with that. And now we're going to remove this here. I can see the pipe going up as well. These are really, really hard to undo. I'm wondering whether it'd be better to use some sort of socket on it. Maybe that's the idea, because if you have a look at them, can you see they're shaped like that? The only thing is, I'm not going to have anything thin enough to get up there, I don't think. I'm going to have a look around because I'm struggling with these 2 here. Right, so I found this, which is what you put your screwdriver and stuff into when you're using something like this. But it's not a perfect fit, but just about, can you see there, it just about fits. Problem is, when I put it onto here, it's not long enough. So what I'm going to do is, when I do it by hand here, I can see that it just barely gets onto it. So instead of putting it fully into this, I'm just going to use the very end bit. If not, I can always use a spanner on this bit here to get it off. So if I just hold that there, just at the end. Oh, there we go, it's out. Not sure if this is supposed to drop down or pull out or what. I'm going to break it. This is attached to it. Actually, I'm not going to be able to pull that out. I'm going to use the camera to see exactly what's behind here, because I can't see with my own eyes. So there's definitely something black there. Maybe that's the fan. No, it doesn't feel like a fan though. Oh yes it does, there's something there behind it. There's something there in front of it there. There. I can feel it with my fingers. Okay, there's definitely a fan there. And these wires here must be connecting to it. Now, if I was to take a guess, I would say that this pipe is going up and feeding all this stuff here, which is, you know, the sort of the fins or whatever you call it. You know, the pipes going along. It does all look very frozen up, and I'm not sure whether it should be like that or not. Thing is, if the fan's spinning, then obviously it's not blocked up with ice, is it? So yes, the motor could be faulty, but it's definitely not blocked. It's definitely not blocked with ice. I'm worried that if I pull this out anymore, that I'm going to end up breaking this pipe here, and this might have that. In fact, it is going to have that gas in it, isn't it? You know, the refrigerants, and I obviously don't want to be. I don't want that getting loose. Okay, I'm going to get back to this video a little bit later because I need the camera now to have a good look around the place, because I can't get my head up here to have a look. So when I find something, I'll start recording again. Well, I'm still none the wiser. It is all starting to melt nicely now. It's all starting to drip down here. And what I've noticed is there's actually a hole here and a hole here, which leads up to the fridge. So obviously this hole here leads to this vent, and this hole here leads to this vent there, which also has that you know, temperature probe in it. So it looks like the fridge, I mean, I'm assuming, because there's definitely a hole at the back there, and I'm assuming that hole goes up to the one in there, but I'm not 100% sure. So, but I definitely know it goes through these vents. So possibly, I'm not sure if this is just for, you know, the temperature, or whether this is how the fridge actually cools down or not. But I think what I'm going to do is I'm going to have to go online and find out what is a frost-free freezer. You know, how does it work? I'm not sure whether this should be all covered in frost or not, because it seems pretty clogged up. But again, that's not going to stop the fridge from working. I can't see how. Anyway, so actually, hold on, thinking about it now, when this is put back there, if it was covered in ice, would it be enough to cover up those holes? Or is it still far away from it? It was very close. I'm not sure. Maybe if this was all covered in ice, maybe it would block up the holes, in which case then the fridge, because I always thought that the fridge was a little bit cold, but not as cold as it should be. The strange thing is, it happened just all of a sudden. It wasn't a case of it was getting worse and worse over time. It did just happen all of a sudden. So I don't think it's that. So I need to find out how a frost-free freezer works, and then what I think I'm going to do is I think I'm going to dismantle that up there as well. So I'm just going to put one screw back in here just to keep it together, dismantle this, and then see if I can work out what's going on. Okay, so about 2 hours has passed. As you can see, it's starting to melt. It's taken a long time. Not much ice is coming down here now, not much water, but it's definitely starting to collect in this tray at the back here. So as you can see in there, you can see some sort of sludgy water. So it's definitely starting to melt, but I believe it can take over 24 hours to fully melt. Now, what I've done is I pulled out the instruction manual, and this is the model number here. So I typed in Electrolux, that number there, into Google, and basically said, you know, fridge warm, freezer cold. And it looks like it's quite a common problem. Now, I don't know if this is the problem with this one, because I need to wait until it completely melts before I can take it apart. But this is what I believe happens. So for frost-free to work, there has to be a heater element to get rid of the frost. Now, as you can see, the frost has built up and built up and built up, and it's turned to a solid block of ice. So there's no airflow here, so that's why my fridge is warm. Now, if I let this go cold, what a lot of people are saying is then their fridge and freezer will work for maybe, you know, a week or up to a month. But then all that will happen is this will block up again, and then I'll have exactly the same problem. Now, obviously I don't want to have to keep defrosting this fridge every single month, because, you know, that's just going to be a complete and utter nightmare. So possibly it could be the heater element that's gone. Now, if you have a look, this is the evaporator, and I believe these big pipes here have the special fluid, you know, the special gas or whatever it's called, the gas going through here to cool it down. But then you have this heater element, which I think is this one here. I won't know until it's fully defrosted. That goes round here, and it wraps itself around the fins and underneath and stuff. And I think once a day or twice a day, this cuts in for about 15 or 20 minutes, and it is actually a heater. It will get warm. It's an element, just like a kettle, and it will melt all the ice off, which will then go via the pipe at the back. This pipe here, coming out here, going down into here, and the condenser heats up because it's running all the time, and this will then evaporate off. So that's how it should work. So the very fact that this is blocked with ice can happen if the fridge door is left open, but normally my kids and my wife are really good with that, so I don't think it's been left open. This seems to have occurred after the power cut. Again, it could be a coincidence, but maybe not. So I've got a feeling it's either going to be a fault on the element, or possibly the PCB that's controlling the element. Now, there is a lot of people say, I don't know about if it's on this model, but a lot of people say that there's a flap somewhere, a motorized flap, that adjusts to let the air in and out, and then it will close, because I'm wondering how else will the fridge be a different temperature to the freezer. So what I'm thinking about doing is dismantling all this, because obviously if that flap was in the closed position, then no air, cold air, is going to get up to the freezer. I'm wondering whether the cold air is coming through these vents here, but there's definitely a hole here, so maybe it comes through there as well. So I think just for curiosity, I should take this apart just to see what's in it. But I did have a look at an exploded diagram online, and it didn't look like there was anything in this bit apart from the light, so I need to double check what that is about. But the very fact that this is built up with ice says to me that this heater is not coming on. So that is actually easy to check. What I need to do is, I just don't know the wires. I mean, it could be some of the ones here, but I don't really know. So when this is defrosted fully, I can then lift up this polystyrene, because right now it's stuck to all the ice, and then I should be able to trace the wires and go across them with my continuity meter. And then, just like a kettle, when I put my two leads on the two wires, if there's continuity, it should mean that the heater is okay. If it's like an open circuit, so if there's no continuity, then the heater's broken. Now, annoyingly, this whole thing here looks like it costs £120, but there is heater elements that you can get for £60, but I don't know if they fit my you know, this particular model. So whichever way, it's not going to be a cheap, easy fix. Maybe frost-free fridge freezers are not all they're cracked up to be, because normally a fridge freezer, the ones I had before, seem to last well, you know, well over 15 years. So not 100% sure at the moment if I do actually want to spend a lot of money on this. But first things I need to do is let that defrost and then also take this apart. So that's what I'm going to do now. That's annoying, I've broken that now. So I'm going to have to glue that back together. Right, okay, so we've got a cable here feeding the light. And oh, we have got a flap. There is a flap here. Right, okay, but it's in the open position. Oh, I can hear the motor in here. Okay, that's interesting, right. Definitely learning here. So if you have a look here, we've got a flap, so this is a motor in here, and if you listen carefully. So the very fact that this is open says to me that it should be allowing cold air up here. So if it was a case of the fridge was always too cold, then it could be a faulty motor in here, because this is being left in the open position, and when the fridge gets too cold, this is going to have to close to stop cold air coming up here. So it looks like there's just the one fan in here which controls the airflow in both the freezer and the fridge. So it's blowing air through here, through this fan here, into the freezer, and then that air is also going up via the well, I don't know whether it's in here or via the holes in the back there, and then it's coming up here and also here as well. So yeah, glad I took that off now, because I was wondering whether there was you know, a flap in there, so I know that. So I think this is all pinpointing to be either a faulty PCB, which is feeding the element for here, or it's a faulty element here. So 100% I'm going to have to defrost this all to get to those wires to test the element. I think realistically, looking at tumble dryers and stuff in the past, I think it's probably going to turn out to be a faulty element rather than a PCB. But then again, I could be wrong. You know what, it'd be nice if it was a cap or something that was faulty in there, capacitor. But I think I'll probably find that it's going to be this, and it's going to be a bit of a pain to change. Now personally, I wouldn't be able to change the whole thing, because that would involve a regas. But if it was just a case of getting the element changed, then I might be able to do that, possibly. So that's what I'm going to do. I'm going to wait for this to defrost. I might even give it a little helping hand with a hairdryer. But I want to be a little bit careful, just in case I was to melt, you know, melt the plastics. So it's just going to be a waiting game now until all this ice goes, and then I'll get back to the video. Okay, so I've put all this back together because I'm sure that that's going to be okay. I mean, I can't verify whether the flap works or not, but the fact that it's open says that the cold air should have been getting into the fridge. So I'm going to put all this back together. I've used a bit of a plastic welding pen to get this back on, and it's strong enough right now. Is it going to be as good as new? Of course not. Will it last when I plug it in there once? Hopefully. If I come to change the light again in the future, then I might have to use the glue or plastic welding again. But I'm hoping, if I'm gentle with it, that it might clip back into place. There we go. Right, so as you can see now, it's nearly full here, so it's defrosted nicely. I've just been emptying it out into the bowl here. So how I'm doing it is, rather than tipping the fridge up, I'm just getting a cloth, soaking it in there, and then just taking the water and squeezing it out. Like that. After I've done that about 10 times, it should all be done. So it's defrosted nicely now. It's lifting in the middle, but look, it's not lifting at either of the edges, and that's because actually it's got a load of sellotape on it, and it's in a real awkward place, so it's been sellotaped around the edge. So what I'm having to do is get a knife and basically just gently, kind of with two hands, pick it up and make sure that, you know, just peeling it bit by bit. So unfortunately I can't film it because both hands are in the way, but I'll give you an idea of what I'm doing. So if I just put that there, and then I'm using the knife, and basically I'm just peeling it back like that, using two hands, obviously being careful not to pierce anything. There you go. And I'm going to have to do that on both sides. So I'll come back to the video when I've done that bit because it's going to take a while. I'm having a bit of a nightmare with this polystyrene. It's just not wanting to budge. I've got the sellotape right down on that side there, and I've got it right down on that side there. So I've got the knife and I've basically just, you know, kept pushing it down and pushing it down and pushing it down here. The front bits are loose, the middle bits are loose, but it just seems to be kind of welded along this bit here. Now I've had a look with the torch and I can see little bits of ice in there, but very little, not much at all. So I'm thinking I might just have to break it to get it out because it's just crumbling in my hands anyway, because it is polystyrene. So this bit here is already broken. You can see there, that's snapped there and that's snapped there. So, you know, I wouldn't say it's too important. I think what it is just to insulate the fridge part, the bottom of the fridge, from this bit here, and to keep this section, you know, colder. So I'm thinking if I was to break it, maybe I could just put fibre tape on the top to sellotape it all back up again. And then you see, as long as it's in the right spot, it's going to provide insulation. Even if it is sellotaped together, it's still going to be better than nothing. Again, it won't be as good as when it was new, but you can just see there, it seems to be stuck in these bits here at the corners. So not really much I can do about that. Maybe it's still frozen, I don't know. There's definitely still ice in this bit here. I don't know, it just seems to be really stuck. And of course I don't want to break the pipe down here, which is the most important thing. So I think what I'm going to do is just snap the polystyrene to do my best to just get it out in as big a piece as possible. There we go. Right, okay, so it looks like the technique is just to push it up from the middle. That's it now. Oh look, it was still frozen at the back. It was probably that was gripping onto it. Anyway, I've got access in there now, so now I should be able to trace the wires with my torch. You can now plainly see the fan at the back there, and I've also got 2 brown and 2 blue wires coming through here, and also looks like a white cable as well. So I need to drop this as much as I can and then find out what's going on. Right, so if we have a look on the left hand side here, you can see that there's like a grey box there, and it looks like that must be a sensor. Possibly it's on this pipe, this copper pipe. So maybe that's a sensor. Well, I think it's on the copper pipe, I can't see. Let me feel it with my fingers. No, it's not. It's on the one above it. So maybe this is like a sensor to feel, for example, maybe how cold it's getting. And it looks like there's also another sensor here with the blue wires. So one sensor's got 2 brown wires feeding it, and one sensor's got 2 blue wires feeding it. This one here on the left. Oh, well, that's interesting. Okay, so what happens is the brown and blue wire comes up from there, okay, on the right hand side, and it goes up and it goes into these weird sensors. So one brown wire goes into the sensor here, and then it comes out of the sensor and goes into the connector here, and the blue wire comes up and it goes into the other sensor, the white one there, and it comes out and again it goes into this connector. So basically this connector then feeds the elements. If I take out this part here, then I should be able to test the wires in here going to the element. So if I have continuity in here, it means then the element is okay, which I hope is the case, because it would be a bit of a nightmare. Alright, so I've got the multimeter. I'm going to set it to continuity, and it's going to make a beep when the wires touch together. So I'm hoping when I put it in here that it will beep at me. It's not. Right, let me see if I can get any reading on it. No, it just says OL, so that's worrying, isn't it? Let me put it to a different reading. Just put it to ohms. OL again. That's not good. That's not good. So that means possibly that the element is faulty if I'm doing this correctly. Yeah, I mean if it's an element then it should have continuity through it, because that's the whole point. It builds up heat just like a light bulb. Right, okay, I think what I'm going to do is I think I'm going to try and take out this element because it will allow me to test it better, and also I'm pretty sure that it is failed, hence the reason why there's frost everywhere. Right, I think the problem I've got here is it's not fully defrosted, it's still dripping, and I think the ice is just sticking it in there, because really this should just drop. I think really this should just drop out of place, and I'm having to put quite a lot of pressure on it. You can tell by the bend on the element there. So I think I'm going to have to let it defrost a little bit more before I do any more of this. So I'll come back to it in a little while. Also, I've just noticed that it's cut me a few times, so I think it would be a good idea to wear gloves when you do this, because these things are like razor sharp. So I think I'm going to find myself some gloves, otherwise I'm just going to be cut to shreds by the end of it. So I'm still waiting on this to defrost, and I've been reading up, and luckily I found like a service manual, a PDF service manual for this, and now I fully understand what happens. So basically we've got the fan at the back there, and it's pushing the air that way. Yeah, and then so what's happening is some of it's going down into the freezer, and then it goes back round and it comes back up here again, and it cycles through like that. Now some of that air that's pushing that way will also go up the duct at the back, and if this damper is open in here, you know, that sort of thing that falls down like that, then it will allow the air to come out into the fridge here. Then when it's in the fridge here, it gets back into the freezer via these two bits here. So it comes out here, circulates around and goes back into the freezer here, which corresponds to the holes that I showed you earlier there. And then it goes round again. Now the fan will only work when the freezer door is cold. And in here we have a reed switch. And this is a magnet here. So when you place the magnet near the reed switch, it makes the contacts. So there doesn't appear to be any more water dripping out, so I'm going to try again now and get the rest of this element out. Oh my god, this is a complete and utter nightmare. Hands are getting ripped to shreds, but I can't put the gloves on because there's just not enough room. I don't want to pull it out anymore because I'm scared that I'm going to break the pipe coming up. Honestly, I don't even know if this is a serviceable part or not. I don't know how I'm going to get it back in, even if I do get it out. It just doesn't seem to be any room. There's room on the right hand side here. Basically, I need to get the cable. Cable's stuck on the left hand side here, and you can see that there's just no room. Probably can't see, it's too hard to see with the camera. Basically I've got it all the way down now, it's just on the last, it's just trapped on the last loop going round. Imagine if I did this and then when I tested it the element wasn't faulty. Imagine if I was testing it wrong. Right, I'm going to have to put the gloves on again. I really am getting cut to shreds like Freddy Krueger. Yes, I got it. Right, let's go take out this mess off an element. looks in pretty good condition, apart from the fact that I've crumpled it all up. I think it says 2262045-01. So I think it's supposed to look something like this. So these ones here go on the top, these bits here, and then all these other ones go on the bottom of it. Like that. So now I just need to look on Google and see if I can find something with the item number that resembles this. So it's the next day now, and I've spent a couple of hours looking for this online and I can't find it. There was a place that used to sell it. It says no longer stocked anymore, and it was £50. I can buy it, but it comes with this part, so it already comes, you know, wound around this part here, and it's £112. So it's an option. I don't want to spend too much money on this, but I probably will have to do that. There is other people selling them for 120, 125, and basically this whole unit comes with a short pipe as well. I think the idea is you're supposed to solder it on. Now I'm not going to do that, so I'm probably just going to be buying the expensive unit and then just using this part of it and fitting it onto here. Now the good news is that I didn't realise that this thing pops off the front. Now when you pop this off the front, it makes it so much easier to work with, because if you look now, if I lift this up, you can see that I can get, well, not, you know, still not easy, but I can get under it now, and it leaves much more room on the left hand side to be able to get your fingers in, to be able to get the wires down the side, because that was the biggest problem I had when I was trying to get it off. So I'm confident now that if I do get this, that I will be able to fit it okay. So now what I'm going to be doing today is just doing some further tests on the different parts of the thing. Like for example, now I've got all this out and stuff, and I also want to check the fan out as well. Now I was watching some YouTube video and it said don't just rely on a continuity test for this one, test it on ohms as well. Unfortunately with the heater here, it's not doing anything on anything. So right now I'm on ohms, and if you have a look, if I put my leads in here, and they're definitely in properly, again it's just like an open circuit. Yeah, the leads are fully in where they should be. And if I do the continuity, nothing's happening. So I'm 100% sure that this heater element is definitely faulty, because my leads are working fine. So I'm 100% sure, no doubt, that that heater element is faulty. But look at these. I'm not happy with these either, because again we're on continuity, and if I test the white one here, so we're going to go into the blues because it's the blue wires going onto this white one. Yeah, if I test the blue ones, you can see I've got continuity, and if I put it onto ohms, it gives me a reading. But now if I go onto the brown ones, which is testing the grey one here, there's nothing happening. And if I go to continuity, again there's nothing happening. And we're fully pushed in there, it's not my leads. So that says to me that this grey one is not working as it should be. So basically these are the defrost thermal cutout and also the safety thermal cutout. So I think it's when the heater comes on, this heater comes on, it's must be this thing that tells it to come on, and then this thing that tells it to go off, or thermal, I'm not too sure. Actually it must be one of them tells it when it gets to a certain temperature, and maybe if it exceeds a certain temperature then the other one kicks in. So let's pretend now that this one is the one that if it exceeds a certain temperature it should kick in. If this is not kicking in, then this is just going to get hotter and hotter and hotter. So maybe originally this failed, and then because this failed, it might have put extra strain on this, which then let this fail. That's the only thing I can think of, because for both of them to go, it's a bit odd really, because it'd be different if, for example, it was playing up for ages and then it went completely, because then I would say, well, this was playing up to begin with, and then when this went, it went completely. But this has been working fine to my knowledge, and all of a sudden it just went. So I think that one component has put strain on another, and then it's led it to break. Or it could be, yeah, I mean that's what it must be. I reckon this went first, followed by this. So it looks like I need a new one of these, and possibly a new one of these as well. But I've got something really interesting to show you, and that is that basically these fridges, I don't know about all of them, but this particular one has like an engineer's mode, a service mode, and you can do all different things now. And I'm just going to, just bear with me, I'm just going to plug everything back in. Remember, I'm doing this with it unplugged, so there's no risk to me. No risk of electrocution. Right, okay, so remember normally these are clipped to the actual pipework at the back, but I'm just leaving them here because they're only on the pipework to measure the temperature. This, because I believe it has failed, it will throw up an error code. So if you have a look now, this is the one feeding the fan, the two white ones, and this one is feeding this setup here. So it goes through here and then onto the heater element. Now let's plug it back in and do the test. Plug it in, turn it on, turn it off, and now hold these two down. Okay, so we know the display's okay, not sure what that one is. That might be just display off. Now this is the compressor, I don't need to do that one. But now this is the heater one. So right now the heater should be getting hot. And what I did is earlier on, I made sure I didn't touch any of the wires, I was just touching this here, and it wasn't getting hot. So I presume this would heat up pretty quickly, just like an electric kettle or just like a, an oven element. And it isn't heating up at all. So there's definitely nothing getting to here. And of course there's not going to be, because this is exactly how it works. Voltage, high voltage, is pushed through a very thin wire in here, just like a light bulb, and because the wire's gone from big to very small, it heats up and it heats up and it heats up and it heats up and it gets hotter, just like a light bulb. That's how a light bulb glows. It's going through a very thin filament, which then gets very hot. So this is not going to get hot because there's no circuit through it. So we know that that's not working. But now there's loads of other things we can check. So let's turn that off. Let's go to number 2 and watch this now. The light should come on and off. Yeah? How good is that? And now let's go to number 3. And number 3 is the fans. Well, right now the fan is off. But now if I reach up and hit the on button, you will see it will come on. Ready? There you go. So I now know that my fan is working. And what it's actually doing is it's blowing the air that way. So it's sucking the air in. So the air gets sucked up in here, goes through there, and then gets circulated back down through here again, and also up to the fridge via that little flap, the hidden flap up here, which we can also check on here. So let's turn the fan off. Watch this. And there you go. Yeah, you can see it's turning off now. Right, so next one. Right, OE basically means that the flap is, let me double check, open. So the damper is open here. So if we now go to on, it's now going to go and it's going to change it. And OO means that the damper is closed. Now listen, it's stopped. So now the damper is closed. If I hit this on again, it will go to OE and it will make a noise. And then stop. So now that's open. So that's definitely working. Next one is the whether the doors are open. So when the doors are open, it will be 1, 1. So one of them stands for one door, one stands for another door. When they're closed, it will be 0. Now I've got my little magnet here. Watch this. Can you see? That one's gone to 0, 1. So that means it's closed. So that means the reed switch is definitely working, because that crossed my mind whether the reed switches were working. Now let me do the same here. And can you see now it's gone to 0. Take it away, it goes to 1. Bring it back up, it goes to 0. So now I know the reed switches are working. Right, what else does this do? Yeah, here we go. Right, this one is the potentiometers here. Can you see now that's working there? And then if I hold this one down here, then I can move. I have to hold this, it's hard to do one hand, but look. Right, let me move it to there, then you'll see. There you go, see it's on 3 now, and then move it to here. Obviously with 2 hands you can actually see it moving up and down. Yeah, so that's now working. This is just like a display with the different colours, so off, blue, red. Now this is the interesting one. E1. And what does E1 mean? It's an error code. Let me show you what E1 means. Code E1, evaporator sensor faulty. So obviously that sensor that I showed you earlier is actually faulty. So how good is that? So what I need to do now is I need to buy myself a new sensors. I think they're 40 or 50 pounds, and I need to buy a new heater element. And unfortunately, I think that is going to cost me that £112. So I'm going to have to spend quite a bit of money, but I'm confident once I've done this, it will be working. So what I'm going to do in the meantime now is I'm just going to put the fridge back together, and I'm going to turn it on just to make sure that both the freezer and the fridge are getting cold, because even with those sensors faulty and also the heater element faulty, it should still actually work for a bit. But then after a week or 2 or 3 or 4 weeks, it will just gum up again with frost, and then it won't be usable. So that's where we are at the moment. I'm going to film it again now when the fridge is back up working again and at the correct temperatures, and then I'll film it again once the spares come through. So I've put the fridge all back together, and it's been working now for probably around 2.5 hours, and it's nice and cold in here. I can see that the ice is starting to build up again because, remember, the heater element's gone. But more importantly, the fridge now is nearly at temperature. Look at that, 7.7 degrees. It's going up now because I've opened the door, 7.9. So it looks like the fan and everything is working right now. So I'm very hopeful when I get the spares through that it is all going to be okay. Now I had a look around the spares, and in this instance it was better to go local. So I've gone to a place not too far away, and they're charging me £104 for the actual heater element and the evaporator. They only do it in one piece, just like online, and £42.50 for those thermal cutout switches. So altogether £146.50, which is a lot of money, but it's still cheaper than going out and buying a new fridge freezer. And if I can fit it, it's going to be a good end to the video, and it's easier than me having to get a new fridge delivered and getting rid of this one. So I'm quite hopeful now when I get those parts it's all going to be working. So the next time you see this now, I'll have the parts, and what I'm going to do is, because the video is getting very long, I'm just going to fast forward through the fitting of them, because it's just the reverse of taking it all out, and then I'll be just doing the final test to make sure that everything's working. So I'll see you later in the week. So it's a few days later now, and I've now picked up my spares. So I've got my thermal cutouts and also the evaporator unit. Hopefully the heater element's going to be wrapped around this. So I'm going to take it all apart and fit it in there. Okay, so I've unpacked them now, and I just want to quickly test them before putting them in there, if you know, to see if they're testing better than the last one. So I'm just going to put this to continuity. And from memory, the blue ones were okay. Let's just try them. Yeah, let's try the brown. Right. Okay, the brown are still not doing anything. Maybe there wasn't anything wrong with the last one then. Let's put it to the ohms. No, open circuit. Back on the blue. Right, okay, do you know what, maybe there wasn't anything faulty with it. Mind you, when I did the engineer's mode, it came up with the sensor that was faulty, didn't it? Strange though, because this new one is testing exactly the same as the old one. I mean, the odds of getting a faulty new one is going to be pretty slim. I'm just going to test the heater itself now, so let's go back onto continuity. Right, there's no continuity there. Let's go to ohms. Right, okay, at least we're getting a reading now on the ohms. So, yeah, we're definitely getting a reading there. That's strange that there's no continuity, but then again, maybe it's, you know, out of this tolerance or something, out of the spec. Just going on to the old one, just on ohms. Right, okay, there's nothing happening on the old one. Right, okay, well at least the new heater is testing differently. When we put this one in, I'm hoping when we do the engineer's test that it will show that it's working okay, because remember it was coming up with that E fault. I can't remember offhand
what it was, E3 or E4 or E2, I can't remember, but I'm hoping when we plug this one in that thing's going to go away. Right, so what I'm going to be doing is I'm just going to be fast forwarding through this now just to speed up the video a little bit because this is a very long one. And then when I have it all installed and turned on, we'll go through that engineer setting again. Now to unhook this thing here, I'm going to get a little, I'm not sure, some little hook or something to try and pull this out because it is in very tight and I don't want to break the middle of it. Actually, before I do that, I just want to check with this old meter about continuity. Okay. Yeah, there we go. And yet on this one, it's not doing it. Okay, so at least the heaters are definitely testing different. Right, to pull it out, I'm just going to get a cable clip, bend round the end of it to make a little kind of hook, and then put them through the middle of each one, because the edges I can get to, it's just the middle that I can't. And then I can just pull out the middle. Very hard to do, and I'm worried that if I bend it too much I'm going to break the element on the inside. I just want to test this again now that I've taken it out, because when you're taking it out it seems inevitable that you're going to bend parts of it. Excellent. Right, at this moment in time it's still working okay. Hopefully when I put it into the fridge freezer, which is going to be really hard, I'm hoping that it will still work okay, still test okay. Put back together, so what I'll have to do now is just tidy up all my tools and then give this a test and then pop it back in the cupboard. Okay, so I've just put it back into the service mode, the engineer's mode, and it's still coming up with E1, which is annoying, which basically means faulty evaporator sensor, which I thought was the thermal cutouts. But obviously it mustn't be, unless the replacement ones I got are also faulty, but I think that's too unlikely. So what I'm going to do is I'm actually going to see if I can test the old ones that I took out before, just to learn a bit more about these thermal cutouts. So I'm doing a quick experiment on these little thermal switches here. So on the service manual it says plus 8 degrees C and plus 40 degrees C, but it doesn't say which one is which. So what I've done is I've popped these both in a kettle of water and I started the boiler. I didn't let it get up to temperature and I took them out. And now if you have a look now, I'm on the blue ones, and before the blue ones did have continuity, and right now there's no continuity. So I'm going to see now, once this cools down to below, because it's still warm, once it cools down to below 40 degrees C, then I'm wondering if continuity will appear again. In which case then I'm thinking that this one would need to be cooled below, the brown one, that would need to be cooled below 8 degrees C for continuity. So I'm going to see if that kicks in once it gets cooler and cooler. Then I think I might try to freeze this one or put it in a bag of peas or something to try to get the temperature of that below 8 degrees C, just to see if I then get continuity on my meter. Okay, and now as you can tell from my meter over here, there is now continuity on the blue one. So obviously the temperature's gone below, I presume, 40 degrees C, and now it's kicked in.
So now I'm going to try to freeze this grey one, and then it will tell me whether this is faulty or not. Remember, this was my original lead. Turn that off. This was my original lead that I presumed was faulty, but maybe it's not. So I'm going to try and cool this now, maybe with a bag of peas or something, and then see what happens. Okay, so I've had this in the freezer. Let's now take it out and see what it's doing. So let's do it on the browns. I can already tell it's all hard. I've got to do this quick before it heats up. Browns and browns. I'm in the browns. Turn the meter on. Let's go to... There you go. Excellent. Well, not excellent because I've just wasted money on a new one, but still. So there's nothing wrong with them. Let me just try the blues now at this low temperature. Yeah. So, okay, just shows you knowledge is everything. This one here is the plus 40 degrees one, and this is the plus 8. So anything below plus 8 degrees C, there will be continuity here. So in other words, it's joining both wires together. And then anything below 40 degrees C, there's continuity on the blue wires. So once we go over 40 degrees C, this one breaks. Once we go over 8 degrees C, this one breaks. So now, bit by bit, as this warms up, it will then stop beeping. So let me just put the wires back in. At 8 degrees C isn't much, so it won't take long. Let's go to, let me just try to warm it up with my hands. I'll fast forward through this bit. And there it goes, gone. You see? Because now it's above 8 degrees C. Well, isn't that interesting? Right, okay. Yeah, so unfortunately I didn't need to spend the money. But now I need to find out why the fridge freezer is coming up with the E1 error code. Obviously it's not these at all. I'm thinking it might be the actual sensors, one for the fridge and one for the freezer. Maybe it's the sensor for the freezer. But when I read the service manual thing, it did say that those error codes will come up in normal operation. You know, for example, instead of going into the engineer's mode, the service mode, it will just come up with certain digits that mean those sensors have failed. But it's still coming up with evaporator sensor. Oh, hold on a minute. Would it come up with that? Ah, it's because the freezer's not working. If the freezer was working, it wouldn't come up with that. In fact, I'll tell you what, let's do it right now. Right, so let's, you can see now we are at minus 15 in the freezer, so let's turn this off. And now let's go into the service mode. Here we go. So it's still saying E1. So why is it coming up with the E1 error code? That makes no sense to me at all. That should be saying E0. So it's a faulty evaporator sensor, but I don't know what that is. Right, I still need to do a bit more research. Okay, so as you can see, it's still saying E1, but right now what I've done is I've unplugged both the temperature sensors. So one to the fridge, which is this one here, and then one to the freezer, which I believe is buried away back in the middle. Back in the middle down there somewhere, but you can't actually gain access to it. These are basically threaded through all the phone parts, so apparently if these fail, that they're supposed to be unfixable or something along those lines. They're not something that you can replace. But now this is interesting. Do you remember I said about an error code that should come up normally? Well, let's go through here and just turn it off. I'm being careful not to touch anything because obviously this is all live. Let me just finish the cycle. Right, okay, now let's turn it on. And now, can you see it's coming up with this symbol here? And that basically means that the temperature probe is faulty. And if I was to press this one here,
you can see again it's faulty on the top one as well because it's been disconnected. So I'm wondering if that E1 fault is just a rogue fault, because if it's not the two sensors there, and if it's not those thermal switches, which I know now are working, then what else can it be? Possibly there's just something out of range here, but maybe it's not actually a fault. Maybe it's this thing that's registering a fault, even though there is no fault, because everything's testing okay. And what I've done is, I've gone across the probes here, when everything was dead, obviously, so unplugged from the mains. I've gone across the probes here, because this is all 240 volts, and it is showing ohms on both of them. And when I open up the doors, the values are changing. So obviously as it's getting warmer, the values are changing. So I don't believe that these are faulty, and I don't believe that my old thermal cutout switches were faulty, and I don't believe the new ones are faulty. And I can't see what other sensor it would be. So I'm thinking I might just need to ignore that E1. Maybe it's been saying E1 since I've moved into this house, and yet this fridge freezer has been working absolutely fine. So I think what I'm going to do with this one is put it back together and just come back to it when the temperature is where it should be.
Okay, so good news. I've been messing around with this fridge and the freezer, and it's all gone up to temperature okay. Right now I've turned it off just to show. If you have a look in here now, it's been on for quite a few hours. There you go. Can you see now? You can see white kind of ice building up on the evaporator. If you look there, you can just see it's like covered, just looks like frost basically. Now, I've had the fridge off for about 20 minutes and it's still covered in white ice, so nothing's really changed. But now I'm going to put it into the engineer's mode, and I'm going to put it onto that heating element one, and you will now see, because I did this earlier, you will now see that the ice goes from it, which is fantastic. So there we go, on number one, turn it on, so we've now got the ice flake, and now I'm going to come back to this in about 10 minutes and you will see that the ice will disappear. So what I'm going to do is I'm going to leave this door closed, just like it has been for the last little while, and now if I come back to it in 10 or 15 minutes and that's completely clear, that then means that it is actually defrosting as it should do. Okay, only 2 minutes have passed and I can already see that there's definitely droplets appearing on it, so it's melting. Right, I'm going to leave it now for another few minutes. Okay, so 5 more minutes has passed, and if you have a look now, it's gone completely back to silver. So in total, probably about 7 minutes has passed. So I'm really confident now that the heater is actually working. It's just that I was sort of expecting to feel the warmth and stuff from it, but I suppose all it needs to do is get a tiny little bit above 0 degrees, like maybe 3, 4, 5, 6 degrees, and that's going to be enough to melt the ice off without starting to melt things in the freezer. In fact, actually, I can feel it's warm ever so slightly here. So I'm really happy with that, because now I'm definitely confident that this fridge freezer is working. So let's turn that off there. And now I'm just going to put it back to normal. It's still coming up with the E1 error code, but you know, I'm going to ignore that now because that could have been here from day one. So I'm going to let it get back up to temperature and then show you the final thing working. Right, great news. I've left it 2.5 days and the fridge and freezer is working perfectly, just like it should do. I had a slight problem with the fan. It could be a little bit noisy sometimes, but that was my fault. I had it in slightly incorrectly. I had the motor bit actually turned upside down. Once I put that back round the right way, it is now as silent as it ever was. And the good thing is it's keeping a nice cold temperature on both the fridge and the freezer. And when I looked in yesterday, I've been, you know, every now and then just looking in with my torch, just shining in on the evaporator, and I seen water droplets on the evaporator yesterday. So that means it must have been in the defrost mode. That was without me doing any engineer's mode. So now I'm fully confident that this fridge is working. I lowered down the temperature a little bit, and now it's reading 6.1 degrees. I think I've got it to 4 up here, but obviously it's going to read different throughout the fridge. What I did is I put it all the way down to 2, and when I woke up this morning, this was at, I think it was at 1 point something. So obviously this does I didn't realise the temperature in the fridge fluctuates quite so much. but I suppose it depends when it's kicking in and kicking out, because that flap, you know, the damper flap isn't going to be like an ideal system. There must be a bit of variation. If you have a look in there now, I haven't had the engineer's mode on for 2.5 days since that last bit of the video, and look, you can still see the fins of silver on the edge there, so it looks like the defrost mode probably worked maybe, I don't know, sometime this morning or last night. But yeah, really happy with it, and I am now convinced that this fridge freezer is working. So at long last, that is the end of this video, and hopefully now this fridge will keep working for the next 2 or 3 years. If it does fail again, I've got a much better understanding of the airflow and how the fridge works. Also, that engineer's mode is going to be a really useful tool if something goes wrong again in the future. So did I enjoy doing this video? I'm glad of the end result, I'm glad it's fixed, but the actual process wasn't that enjoyable purely because of the confined space and also working with that evaporator with all those fins cutting your hands up anytime they went near them wasn't that enjoyable. But saying that, my hands now are healed or starting to heal, and the fridge is working, so it will all be forgotten about, and also I've learnt now for the future more things about this fridge, so if it fails again I'm a lot more confident now than I was at the beginning of the video about fixing this fridge. So hopefully you enjoyed it. Apologies again for the long video, but if you did like it, please give it a thumbs up and please subscribe for more how-to videos and fix-it videos as well. Take care, bye now.